So these are the points I'm focused on, guys. So here we go, guys. Let's go ahead and start. So here we go, and I have this function. We're going to call this f of x. And these are the coordinates that I'm taking. -3, -3. -2, -2. -1, -1. 0, -1. 1, 0. 2, 1. 3, 0. Do you guys see those coordinates? Okay, I'm going to make a table right here. X, f of x. And I'm going to go from -3 to 3. All I'm doing is plugging the y coordinate from that graph, guys. -3, -3. -3, -2. And in case you're wondering what I'm doing this. F of -1 is -1. F of 0 is -1. F of 1 is 0. F of 2 is 1. And F of 3 is 0. Are you guys okay with that? I just didn't do the top two. I guess you could have just F of -3 is -3. And f of -2 is -2. You don't have to write that. I just wrote that because it'll be easier when we do other questions. You can just go right into the answers. Are we okay with that, guys? All right. So here we go. I have this, and it tells me that I'm doing absolute value of f of x. It wants to know how this graph is going to look. Now, can you already predict how it's going to look by looking at this one? I hope so. I hope so. So pretty much if you're above the x-axis, you're going to be left alone. And if you're below the x-axis, you're going to reflect across the... Yeah, that's what's going to happen, guys. So here it is. I'm going to go ahead and draw a table for those of you that love tables. I'm going to go -3, -2, -1, 0, 1, 2, 3 again. Absolute value of f of -3. Well, f of -3 was -3, so absolute value of -3 is 3. Do you see how we're doing it? All right. So this is absolute value of f of -2, and well, absolute f of -2 was -2, and absolute value of -2 is 2. So we're doing the same thing over and over again, guys. If you want to just go ahead and just do your thing. I think f of 0 was also -1. What was f of 1? 0. And f of 2 was 1. And f of 3 was 0 again. And I'm just going to plot those points. And it should not be a surprise. -3, 3, point, -2, 2. -1, 1, 0, 1, 1, 0, 2, 1, 3, 0. Oh, man. And just as you said, what happened?
All the negative values, well, not all the negative values are reflected across the x-axis.
Perfect. I'm going to put all negative y values were reflected across x-axis. Positive y values were left as is, or left alone. I just put as is. Oh, sorry. All negative y values were reflected across the x-axis. Positive y values were left as is, or were left alone. I should have put original positive y values. Original positive y values were left as is. Okay. Oh, sorry. I wish I had a tap here for unlimited supply of coffee. Just that would really make this classroom wow. That and some pyrotechnics. I push a button and then that would be awesome. One day maybe. All right, same thing with this, guys. Notice the absolute value is this time on the x. So x, f, absolute value of x, close. So let's see what that is. -3, -2, -1, 0, 1, 2, 3. And I'm not insulting your intelligence. I know some of you have practiced this a whole bunch of times already. So that -3 there is going to turn into a positive. So I'm going to have f, absolute value of -3, so which means f of 3. And f of 3 was, do you guys remember? 0. Good job. So this is going to turn to f of 2. And f of 2 was 1. This one's going to turn to f of 1. And I believe f of 1 was 0. And then after that, everything else is still the same. This is f of 0, so -1. This is f of 1, so back to 0. This is f of 2, 1, and then this is f of 3 again, so 0. So plot those points. -3, 0, -2, 1, -1, 0, 0, -1, 1, 0, 2, 1, and 3, 0. What happened? Oh, we'll wait. Yeah, compare it to our original. What happened?
Everything like positive, I guess, positive x values are both reflected. Like everything on like half of the graph, the y-axis. Like,
So all anything in quadrant 2 and 3, that's where x is negative, right? Everything in quadrant 2 and 3 was deleted. And then the better word, I think, is mirrored. And everything in quadrant 1 and 4 was mirrored across what axis? Y. Now, if you say reflected, we wouldn't count it wrong. I know what you're saying. But mirror is the better word. Because when you stare at a mirror, you see yourself and you're still there, right? And when, yeah. I think mirror is a better word. But if you say reflect, that's fine. Let's see. What am I going to write? Negative x values deleted. No, I'm just going to say quadrant 2 and 3 deleted. All original points in quadrant 2 and 3. That's a 3 there. 3 were deleted, semicolon, and then quadrant 1 and 4 was mirrored across y-axis. Okay. All right, this one, hopefully you guys have experience with this one. What's going to happen?
it's gonna put you across the y-axis.
Yeah, it's going to reflect across the y-axis. Everything. So here we go. X, f of negative x. Really, that just means change the polarity, guys. negative 3, negative 2, negative 1, 0, 1, 2, 3. So this means f of 3. F of 3 was 0. This means f of 2. F of 2 was 1. This means f of 1. F of 1 was 0. F of 0 is still negative 1. Now this one gets to f of negative 1. F of negative 1 was negative 1. F of negative 2 was negative 2. And f of negative 3 was negative 3. Plot the points. Negative 3, 0. Negative 2, 1. Negative 1, 0. 0, negative 1. 1, negative 1. And just like Abdul Karim said, everything was just flipped or rotated, or I wouldn't say use the word rotated because that means circular motion. Everything was just flipped, or you can say reflected across the y-axis. You can take the whole box. Okay. What's up, miss? How I got the graph? Oh, well, this says negative here. So negative times a negative is a positive. So now I have f of 3. And then I just went to my original, and I saw what f of 3 was. F of 3 is 0. See what I did? And I did that for all of them. So really, all you got to do is change the sign, right? So plug in a negative 2, it turns to a positive, and then f of 2, and I just went to the original, saw my original, and then that's how I plot them all. Yes, miss? Oh, I got you. No. If you have an idea of how the graph looks, you will get it. So let's say... so this is a side note, guys. So that's a good question, Ms. Guajardo. So y equals square root of x. Do you have an idea how that one looks? It looks like this. Right? Okay. So now that you know that y equals square root of x looks like that, if I tell you, okay, well, how does y equals square root of negative x look like? Like, oh, well, earlier we did something, look, that's negative x, and it reflected across the y-axis, so it must be the same graph, but reflected across the y-axis. Cool or not cool? Yeah. See? So now there are certain graphs that are going to stay the same, like x squared, right? So negative in the well, okay, it depends. We got to be careful. Y equals this obviously goes downward, but if you say negative x squared, that's still the same thing as x squared, right? So you got to be careful because these are not the same. Okay, this one's the most important one. Take a guess before we even get started. What happens? Compression? Vertical compression? Be careful. Is there a half in the front? Horizontal compression? Are you 100% sure? Do you want to use a lifeline?
Yeah, because on the x, so the x would be this diminished value, and if it's half the value, then it's
So you think it's a compression, huh?
oh, fudge!
It's a stretch. Now, let's see why it's a stretch. Like, let's not be robots. Maybe Ms. Torres told you if it's between 0 and 1, it's a stretch. And if it's a magnitude greater than 1, it's a compression. Let's see why that is. I need some x value that when I multiply by half, the only answers I know are these. Are these from the original. F of 3, f of 2, f of negative 2, f of negative 1, f of 0. So I need some x value that when I multiply by half, I get f of negative 3. What x value would that be? Negative 6, no? So I get f of negative 3. So maybe I didn't ask the question correctly. Maybe it was my fault.
No, you didn't.
So here we go. So let me say it again. Some number that when I multiply it by half, I get a negative 2 because I only have f of negative 2. So what is that number?
Negative 4.
Negative 4. So half times negative 4 is negative 2, and I have f of negative 2. Bless you. That is negative 2. Do you guys see what we're doing here? Don't worry. I'll help you out. I'm going in order here. So I want this number that I multiply by half, I want it to be a negative 1. Chavez, why? Because these are the values that I have on record already. So what x value times half will give me a negative 1? Negative 2. F of negative 1 is negative 1. And then a 0 is just a 0. Let's see, f of 2. I'm just going to put the answer for the rest, guys. F of 2. 2 times half is 1, so f of 1 is 0. Half of 4 is 2, and f of 2 was 1. Half of 6 is 3, and f of 3 was 0. So let's plot those points. Negative 6, negative 3. Point. Negative 4, negative 2. Point. Negative 2, negative 1. Point. 0, negative 1. 2, 0. 4, 1. 6, 0. What happened? That's right, horizontal stretch. If you were to take that x-axis and pull out both ends, that's what would happen. It's a horizontal stretch by what factor? No. By a factor of 2. The old x values were negative 3, negative 2, negative 1. What are my new x values? They were multiplied by 2. Cool or not cool? Okay. So don't worry, we can talk about it later, miss. I just want to get through this really fast. All right, so why are we discussing this? Because, so there's a side note. Don't write this down. If I tell you something like this, cosine x, and then I write y equals cosine half x, without thinking, you should be able to tell me the period real fast. At least I hope. Cosine x, if we're in degrees, has a period of 360. And cosine half x, we know it's a horizontal stretch by a factor of 2. So cosine half x has a period of 720. 360 times 2. Right? Now you don't have to do that, guys. Look, you can always do this. B is equal to 360 divided by period. And check it out. It'll work, but I want you guys to see the math. Like, you don't have to be a robot. You can say period equals 360 divided by the B. Well, the B is a half. And look at that. 360 divided by a half. Well, keep, change, flip. That is 720. Cool, right? But I want you to see how everything's related. You can just look at it and be like, oh, half. Well, it was 360. 360 times 2 is 720. Because of that half. Because of that. It's the same thing. Oh, you guys don't seem impressed.
Yeah.
But cool or not cool? Okay. Let's see. What do we got left? That's it? Oh, okay. This one's simple. What do you think is going to happen on this one? Which one? Right or left? Uh-oh. It's going to move to the right, guys. So for those of you that have always wondered why is it always the opposite? Now, this is not really a formal definition, but it will help you. So, what's up, miss? Oh, because I need values that are on my original. I know what f of negative 3 is. F of negative 3 is negative 3. So, because I know that, if I plug in a negative 2 in here, you get f of negative 3. See? If I were to start at a negative 3, I would get f of negative 4. And I don't have a value of negative 4.
So you're trying to get your original y value?
Yes, I'm trying to get to my original. To values that I do know. Good question, by the way. Now you can see why everything moves to the right one time. Look. Negative 1 minus 1, that's negative 2. F of negative 2 is, I already forgot, negative 2. F of 0 minus 1 is negative 1. F of negative 1 is negative 1. F of 1 minus 1 is f of 0, which is again negative 1. F of 2 minus 1 is f of 1, which is 0. F of 3 minus 1 is f of 2, which is 1. And then f of 4 minus 1 is f of 3, which is back to 0.
So then we completely disregard the negative 3 of the original coordinate because that would technically be f of 4. F of negative 4, we don't have that.
Correct. It's not in the domain. So that's why we started at negative 2. So negative 2, negative 3, negative 1, negative 2, 0, negative 1, 1, negative 1, 2, 0, 3, 1, 4, 0. And there's your graph. And notice, did it move one time to the right? Yeah. So hopefully this cleared up a lot of confusion. If you guys even had confusion from algebra. Plus this was also a good vertical alignment deal because we missed out on the whole pandemic stuff. So did this help or no? Okay. And now we finally get to the fun stuff. Oh, I just put horizontal shift 1 to the right. Horizontal shift 1 to the right. All right. So here was the game plan when I typed these notes out, guys. So here's what I noticed. I adjust. I always adjust. I'm trying to be the Michael Jordan here of math teachers. So here's what I observed. I observed if I do a whole bunch of different questions, you guys are like, I don't know. And then I do another one, and like, I don't know. And then I do another one, I don't know. So I adjusted, and I'm just going to do one question over and over again. The same graph, different ways. Because, you know what I mean? So instead of doing a whole bunch of different graphs, I'm just like, you know what? We're just going to do the same graph. Same graph, different equation. Over and over again. Different attitude, different perspective. So this question here, so hopefully it works. We'll see. This question here is from your homework. It might not be the exact one. Or I think it is. Or maybe it's from your notes. Yesterday's notes. Or last week's notes. I can't remember anymore. Short-term memory. This is one of the questions you guys have been missing on your homework or your activity. This is a quarter of a cycle. How many quarters does it take to complete a whole cycle? Yeah. So hopefully, if this is a quarter of a cycle, you guys immediately know that this has to be the min. And this, the min, that's the minimum. And that this has to be the midline. So a quarter is always going to go from the min to midline, or from a midline to a max, or from a max to a midline. Right? All right. So if that's a midline, and the difference between 8 and 3 is 5, then where's my max?
13.
Perfect. So go to 13. This gap here is, what's that, 7 degrees? That gap there is 7 degrees. So go from the point of inflection on the midline to a max. I'm going to go try to make it symmetric. So I'm going to label it right here. I'm going to put 10 degrees. I'm going to put a point at the max. And then put a bowl there. And try to aim it right at the point of inflection here. I'm going to go another 7. So I'm going to say this is 3. And I should have a point at the midline here. So it looks pretty good. So there it is. I got a point at 3,8 and a point at 10,13. A point at 17,8 that was given, and then 24,3. I'm going to go another 7 from the 24. So I'm going to say 31 degrees. Midline. And another 7 one more time. Does everyone know how I got those numbers? All right. Let's come up with an equation as a class. What do you guys want to use, cosine or sine? Cosine? We're going to use sine, I promise. Let's use cosine. What's the amplitude? 5. Cosine, open parenthesis, I need the b, so I'm going to go here to the side. B is equal to 360 divided by the period, because we're in degrees. The period is 28. So I'm going to take my calculator, and I'm going to go 360 divided by 28. I'll push enter, math, fraction, enter, and I got 90 over 7. Leave it as 90 over 7. 90 over 7, open parenthesis, x minus, if I use cosine, I have to use a peak. What peak do you guys want me to use? The first one. 10, close, close, plus, what's your midline? 8. How do you guys feel? Okay. So here comes, so go to the second page. And voila, that graph is the same graph we just did, but we had to practice. And we didn't change anything. Equation we came up with as a class, y equals 5 cosine 90 over 7, parenthesis, x minus 10 degrees, close, close, plus 8. And here was my, here we go. We're going to answer a whole bunch of questions with the same graph over and over again. Now, before we continue, let's make sure that this graph is correct. So I'm going to go to my calculator. I'm going to go to y equals, and I'm going to type that equation. What was it? 5 cosine 90 over 7, open, x minus 10, close, close, plus 8. Now, if y9 down here, you see that I have y equals 8. That's my midline, because I want it to come out pretty. So there's my graph, and there's my midline. I'm going to push trace, and I'm going to see if it works. At 3, I have a point at the midline. So 3, enter. Do I have a point at the midline? Yeah. At 10, I have a max. So I'll push 10. And yep, sure enough, I have a max at 13. And then again, what's the next one? 17? 17, back at the midline, 8. And then I have a minimum at 20, what, 24, 23? 24. And look at that. It works. Are we good, guys? All right, let's go back. Here we go. For this sinusoid, write a particular equation using cosine with a phase displacement other than 10. So they want me to do the same thing, but a different phase displacement. So not 10. Give me another one. 38. So I'm going to write y equals 5 cosine 90 over 7, parenthesis, x minus 38 degrees, close, close, plus 8. And that's it. You're done. It's the same graph. Cool or not cool? All right, here you go, Romero. Ready? Oh, I caught it, guys. Mosquito. See? Right there. All right. Why are mosquitoes? Well, let's just continue. Here it is with a sine. If I'm going to do it with sine, we have to use a point of inflection on the way up. Chop this, but why? The parent function for sine x looks like this, guys. It looks like this. So I'm using that point of inflection. Notice that you read a graph left to right, point of inflection on the way up. I know this is another point of inflection, but that one's on the way down. Cool or not cool? Cool. So if I use sine, I need a point of inflection. There's 2 of them on the way up. Well, there's a total of 3 that I see, but there's 2 of them that I can use. Which one and which one?
3 and 31.
Perfect. 3 and 31. It doesn't matter which one you use. So here we go. Y equals, I'll put them both. 5 cosine 90 over 7, x minus 3. Oh, yep. Sine. 90 over 7, x minus 3, close, close, plus 8. Or y equals 5 sine 90 over 7, x minus, what did you say, guys? Tell me? 31. They will both give you the same wave. Yay or nay? Okay. Here we go. Letter C. It says cosine with a negative vertical dilation. Uh-oh. So now they want a negative. All right. So here we go. What happens? Let me go ahead and erase this part here, guys. So just listen. Put your pencils down really fast. So I have y equals cosine x. It looks like this. What happens if I write y equals negative cosine x? Your max become mins and your mins become max. Perfect. So it looks like that. Yes or no? Yes. Okay, same thing. So here's what I'm going to do. Don't write this down. I'm going to give you plenty of time. I'm going to put a graph in here, and you guys are going to tell me the equation. And I'm just writing this blue graph here just for fun. Don't worry, in a little bit I'll let you guys write. It kind of looks like DNA. Do you guys see that blue graph? If I told you to give me this equation in terms of cosine, okay, so now you can write. What is that equation of that blue line in terms of cosine? No negative, no nothing, just in terms of 5 cosine 90 over 7 x minus, yeah, you could also do with a plus 1, x minus 24 plus 8. Does everyone agree to that? Okay, so write that down real quick and then we'll talk deeply. Yes, because you are at a max to the left of that y-axis. Yes. All right, you guys ready? Here comes the big moment. If I put a negative in front of that 5, I'm just looking at the blue graph. Does that blue graph turn into the green graph? What do you guys think? Yeah, the max become mins and the mins become max. Does that make sense, guys? That's if you put a negative. I'm not going to put a negative right there because that graph really is that. I'm going to put a negative down here. So here I'm going to write that same equation in blue, but with a what in the front? Negative. Y equals a negative 5 cosine 90 over 7 x minus, and I already forgot. What was it? 24? Perfect. X minus 24 degrees, close, plus 8. And there it is. That blue graph will turn into that green graph, which is the one that I want. Does that make sense to you guys? Perfect. Yes, ask, please. Say it again. I didn't hear you. What's the difference between finding a what? The period is going to be the same for both cosine and sine because it's the same wave. Everything is. You could not have done 38. No, because 38 is a minimum on the blue graph. You know what I mean? No, because if I put a negative on the, I need to choose a peak on the blue I need to choose either 24 or I need to choose. You cannot choose 10 and you cannot choose 38 because 38 has a peak on the green, and if I put a negative in the front, that green turns to the blue graph. Do you know what I mean? So you can't put. It's like if you choose this one here, you can't put a negative there because then that green graph will turn into the blue graph. If it was in radians, yes. This is in degrees, so we're doing 360. Well, 360 divided by 28, no? Well, I just did 7 times 4, but the difference between 38 and 10 is 28. Peak to peak, that's 28 degrees for the period. For the B, yes. The B? The 90 over 7? Okay, that is your B, and you get 360 divided by period. And that's going to be the same for all of them, sine, cosine, because they're the same wave. And I thought that's what you were telling me. Okay. What's up, miss? The 28 degrees, what about it? Well, I got it from a quarter of a cycle with 7 degrees, and then I need 4 quarters to complete a cycle, so 7 times 4. But you don't need to get it from there. You can also get it from the graph. You can get it from peak to peak. The difference between 38 degrees and 10 degrees is 28. What's up, Miss Romero?
Is weight going to be with the unit 2?
Yes, but it's not any tricky questions. All basic ones.
So this would be on our first time exam.
Oh yeah, definitely. All right, last one. Sine with a negative vertical dilation. So the same graph, the blue one. Give me that graph with sine. Y equals, everything's the same except for your C. 5 sine 90 over 7 x minus 17. Close, close, plus 8.
Is that the only point that...
No, you could use, well, that's the only point that I can see here. But there's another one right there if you go another 7 from 38. Cool or not cool? All right, now that's not the curve that I want. I don't want the blue one. I want the green one. So what do I got to do to that blue curve? Put a... Perfect. So I come back over here, and I'm going to write y equals negative 5 sine 90 over 7 x minus, and I already forgot, what was it? 17. Close, close, plus 8. All right, let's check to see that they are all correct. I'm going to go to my calculator. Hook me up with, what was the sine one? The first one that I got, letter B, I think. 5 sine 90 over 7. And then what was the Y3 was letter C, so negative 5 cosine 90 over 7 x minus close, close, plus 8. And then finally the last one was a negative 5 sine 90 over 7. We're just, yeah, x minus. All right, it's gonna go really fast, guys, so check it out. I want to see my graphs overlap. They're all gonna be different colors, and they're gonna be preceded by the next one. Ready? Well, if I did it right. There it is. There's 1. There's 2. There's 3. One more. Oh, wait, I already did it. So there it is. They all work. Cool or not cool?